Would you say that better tools make you a better worker? I wouldn't. Instead, I would argue that better tools make you work faster. Better tools mean you can do what you want to do faster and with fewer hiccups. Where am I going with this? I'm developing a story-based indie game called Soulflame, and in every good story-based game, there is one tool that the storytellers always use: cutscenes. And right now, my tool isn't very sharp. If I'm going to start writing more cutscenes, I want the process to be as simple as possible, and what I have right now won't cut it. So, let me introduce you to my process. Compile times. You know the feeling you just got? It's the same one I get every time I recompile the game. Soulflame is getting larger and larger. I have more graphics, enemies, rooms, and systems than ever before. So every time I recompile the game engine has to bundle them together into a single application. And how long does that process take? Let's see. But anyways, how does that relate to cutscenes? Simple. Every time I change a cutscene, I have to restart the game. No way around it. And after that, I can't just watch the part I changed. The game restarted. I have to sit through the entire cutscene, and that is a lot of time waiting and not deving. So as I make cutscenes longer and longer, the time spent developing it grows and grows. This is not sustainable. Today's video is about me upgrading my cutscene system, and the changes I made that let it actually behave as the tool I've always wanted it to. My cutscene system was based on this tutorial from the YouTube channel Friendly Cosmonaut. It's a great system. I 100% recommend this tutorial. What you're watching is the opening cutscene of the game, and here is the cutscene code. It looks a little overwhelming, but I'll explain it. When the room starts and the area is loaded, each trigger runs a little bit of code in their creation code event. It sets this up, the cutscene event information, as well as some other details regarding the trigger. The triggers also handle some logic to delete themselves in the event a cutscene has already been seen. When the player triggers a trigger, a cutscene instance is created, which then copies the information from the trigger to itself and then runs the cutscene. As the cutscene progresses, the cutscene object is looking at an element in the scene event list. When that specific event is finished, the cutscene gets notified, and then it moves on to the next event. Makes sense, right? Let's put them side by side to see how the system works. Each event has a bit of logic describing what the event should do. So, in this case, move Ella over here, and you can see it does just that. Some logic is handled by the objects themselves. For instance, Ella moving. So in that case, the event also waits for the condition to be met. So what happens when I want to change a cutscene? Well, I already told you. I gotta close the game, recompile, and watch it again from the start. So my first order of business was figuring out how I can change that. I did a little research, and I came across this tool called GM Live. This allows people to hot reload code into their active GameMaker application, meaning I can skip the compile time altogether. GM Live was made by someone called Yellow Afterlife, one of the goats of GameMaker. After I set it up, I went to try out the fix for the cutscene loading. But unfortunately, the process that I use, the creation code event, doesn't really wrangle nicely with GM Live. At least, not the way I was hoping it would work. Actually, GM Live not working with my cutscene system is actually kind of a blessing. I'll use this as an opportunity to change some of the aspects I didn't really like about the cutscene loading. So what are those problems? Let's go over them. My first issue is what we just discussed, that the cutscene loading doesn't work with GM Live. The second, I don't like that the trigger is the thing that's setting up the cutscene. If I define variables here next to the cutscene information, those variables aren't automatically transferred to the cutscene. And since triggers might be destroyed after the cutscene loads, there's no guarantee we can access them at runtime.
Who are you talking to right now?
Third, and this follows again, it's kind of hard to reuse cutscenes. Because the code is attached to the trigger itself, I can't just define it once and maybe reuse it again later. If I did, I'd have to copy the whole trigger, and the cutscene information might be the same initially, but they're not linked together in any way. If I wanted to change both, I would actually have to go in and change both, instead of just changing it once. Problem number 4, branching. Remember, the cutscene event information is created at the room start, and I can't really easily change things after the fact. Let's take this campfire cutscene for example. If I'm on the left side of the campfire, I sit down on the left side. But what happens if I'm on the right side? Since any condition evaluates at the beginning of the room, we have no idea which side the player will be on when the cutscene runs. Right now, I just default to making the player sit on the left side every time. And lastly, I've said this before, I have to watch the entire cutscene every time I want to edit the end. It would be really nice if I could skip parts of the cutscene. And with these problems in mind, I spent days, nay hours, nay minutes, nay seconds, figuring out what I needed to do. And to do it, I'm going to employ one of GameMaker's new features. The solution is not to upheave my entire cutscene system. Almost every problem stems from the fact that we create the event information in the trigger when the room starts, and then only pass it on when it's needed. Let's instead defer the creation to a new specific script I'm going to call a scene. Now, the trigger holds this scene script and passes that to the cutscene object. The cutscene object then runs that script, which then creates the event information. Nothing about the cutscene's run has changed. It's just the loading. And that works wonders for 1, 2, and 3. For 1, GM Live loves reloading scripts. It's basically what it was built for. 2 is pretty self-explanatory, and 3, it's really easy to recreate cutscenes. We'll just run it multiple times. But cracking number 4 is going to be a little harder than that, and it involves slightly changing how I write the cutscenes. To do it, I'm going to write something called a domain-specific language. Specifically, I'll write a compiler for an embedded DSL that takes a more general instruction set and turns them back into a form the cutscene object expects. If you're liking the video so far and want me to go more in depth into some of my own game systems to potentially even learn more for your own games, please consider liking the video or even subscribing. It would really help me out as a one-man game dev studio. I do all of the coding, art, and video editing for the game, so any amount of support would be amazing. Anyways, back to the eDSL. Let's go through and create the embedded DSL together. Let's think about the lowest level of what we're trying to accomplish. The cutscene is a list of events. So let's abstract this a little. Instead of having a list of scripts and arguments, let's instead hold a scene, which contains events. Let's use a super helpful feature of GameMaker called structs. It's your generic map, dictionary, hash map, whatever. Let's create 2 different structs to fit this little scenario. One called scene object and one called a C event. C stands for cutscene. We'll make it so that a C event is simply just going to hold the event from before. So this just becomes this. The scene object then takes in a list of these C events and stores it in its own internal list. Now, while we're running the cutscene, when we ask for what the current event is, we just pass back the correct C event, and everything works the exact same way as before. Okay, we have a basic setup now. And yes, what we've really just gone ahead and done is move some data around. But where this gets interesting is by giving the scene object a little extra job, consolidating other scene objects. So let's pass in a scene object into a scene object. What should happen? Well, we should take the events from the inner one and insert them into the outer one. That can be done on the insert phase of the outer, because at that point, the inner one will already have been completed. Now, with this functionality in place, it means we can write parts of cutscenes in separate objects. And that means if I just turn off this object, we skip all of the logic. That's pretty good. But still, this is kind of ugly, right? We're still defining all of the structs like this. Instead, let's do one last layer of abstraction and adding functions to create these structs for us. So instead of calling a new C event, cutscene event wait seconds 0.2, I can just call C wait 0.2. That's nice and simple, but what's more is instead of just doing a one-to-one mapping, I can instead make a function return a compound event by returning a scene object with multiple events inside of it. But that's not it. Now we can add a type of branching, a C branch. It'll take a condition, a true branch, and a false branch. When the cutscene is created, it will evaluate the condition and then choose the correct branch to insert into the scene. Remember that cutscene example? With this change, we can now do the campfire example from before, because we can now check if the player is on the left side of the campfire at creation time. And lastly, I've also introduced a new type of C event called a C label. C labels will allow me to assign a name to events in the cutscenes. This, in conjunction with the new event type, a break, will allow the cutscene controller to jump into any part of the scene. Now, all of these combined makes the cutscenes much more powerful. And I didn't even change the underlying logic at all. But this new version makes writing cutscenes much more human, and it's super easy to see how the cutscene functions and branches just by looking at it. Which wouldn't be exactly the same if we just looked at the previous version. But there's still one last problem I had, remember? I want to be able to skip parts of a cutscene. And actually, now that I think about it, I want to be able to skip the entire cutscene. How should I go about doing that? Well, let's start off by extending the functionality of the previous version. If an event runs in one frame, we should immediately move on to the next one and perform that event as well. In the old system, setting the horizontal and the vertical speeds of a jump took place over 2 frames. You'll see as we step through these frames, we're also stepping through the events. In this new way of running events, it just takes place in one. But this change now sets us up really well, because if you think about it, we can just add a flag that forces every single event to be run in one frame. And doing the whole cutscene all at once is just skipping the cutscene. That's exactly what we're going for. To show this, I've just modified the campfire sit-down cutscene. Instead of sticking close to the campfire, we'll just move really far away from it. Because it's actually impossible because Kira gets stuck, the only way we can fix this is by skipping the cutscene. This will force every event to run in one, and in this case, set Kira's position to be that -500. And when we're done simulating the cutscene, you'll see that Kira ends up at that position, because we skipped the cutscene. And now, I've solved all the problems I've had with the current cutscene loading. This will let me make my cutscenes way faster. I'm not sure by how much though. Let's write a cutscene together. About a week ago, I posted a YouTube short about this animation I made in Sprite. I want to add it to the game now, and it's the perfect opportunity to try out the brand new cutscene system. Let me describe what the animation is about. This character, whose color palette has a striking resemblance to a certain family man, vaults over a wall and then fires a rifle. It has a bit of a charge up, and then it fires an orange blast, which you can't see right now, but you can see it reflected on the sprite. And then, at the end, he'll get captured by an enemy. And here's the shot. I'm putting it on its own sprite because it's going to glow, so it needs to be separate from the other animation. So I'll create the cutscene trigger and then move Peter into the correct position. And if I run the game, you'll see that Peter is in the right spot, and you'll also see the monster that he's going to shoot at. I've broken down the animation into different sections. So in the cutscene, all we have to do is switch Peter's state, and he'll do that exact part of the animation. So let's start writing the cutscene. First we'll wait for a second, then we'll set Peter as the target of the camera, and then we'll make him sit up. And if we go into the game, that's exactly what you'll see will happen. Cool, and that was really easy to write out. Let's make him do the vault, wait until he's ready, and then charge his gun. Now look at the code again. We wait for 3 seconds, set Peter to charge his gun, and then that's the last event, which means the cutscene is going to end. And you'll see that's exactly what happens. I'll finish adding the states, and then make sure the monster turns around after the gun shoots him. We'll add the shot animation in a second, but you'll see we have the whole cutscene quote-unquote ready. I'm gonna go ahead and import the shot animation after making sure the distance is somewhat right, and then we'll see how it looks in-game. What was that? The animation and effects look good, but the shot comes out a little too early and it's a little too low. The shot appearing too low was because I forgot a negative sign right here. Here's the thing though, if I change something about the cutscene to fix it and then rerun it, I'm still gonna have to sit through the whole cutscene to make sure if it works or not. So let's start skipping the cutscene. I'm gonna add this tiny little block of code that checks if we're skipping the cutscene, and if it does, it just stops the skip. Now in game, when I trigger the cutscene, we'll run all of those events, culminating in Peter already being up top, ready to fire. I've also went ahead and added some knockback to Peter when he shoots the gun, and I've extended the cutscene a little bit to showcase what the boss is able to do, because this is obviously a boss, guys, right? Here, Peter's trying to reload the gun, but then he gets snatched up by the boss. And then the boss jumps away, Peter in tow. I wonder whose job it is to fix it. And that whole sequence is built using the code you see here. And writing it was much more natural than what I had to do before. I want to note that the original tutorial by Friendly Cosmonaut goes in much deeper in how the cutscenes and events actually work. And also, I want to be clear, I'm not knocking on her tutorial or system at all. It's just, as my needs change, a beginner's tutorial isn't going to cut it for the game anymore. So if you're curious to start your own cutscene system, definitely check out her tutorial. And then if you're interested in the upgrades I've made, you can come back here and try to follow along with what we went through here. I'd like to thank you for making it all the way to the end of the video. If you liked it, please consider leaving a like on the video, or even subscribing. I do a lot of game dev related videos, and maybe even in the future, videos on pixel art as well. That being said, I hope you have a great rest of your day, and I will hopefully see you next time.